Hello everyone. Today we are going to see examples which are depend on the completing the square, method of completing the square. Okay, already you have seen such type of examples, but now we are going to see how to solve the examples of the same concept, but little bit different examples. Okay, this is level 2. We have seen level 1. Now we are going to see level 2. What is given? See, 4x square plus 4bx minus in bracket a square minus b square is equal to 0. This is the given quadratic equation. Okay, so that I am taking here, we have 4x square plus 4bx minus a square minus b square is equal to 0. This is the given quadratic polynomial, quadratic equation. Okay, so according to the rule, the coefficient of x square we need to convert into unity. Okay, coefficient of x square should be 1 unity. Okay, so for that what we are going to do, we need to divide all the three terms by 4. Okay, so after dividing by 4, what we will get here? 4x square divided by 4 plus 4bx divided by 4 minus a square minus b square upon 4 is equal to 0. Okay, so this step directly also we can write 4x square divided by 4 means what is going to remain here? X square. So that x square I am taking here x square. So x square plus 4 divided by 4, this will be cancelled. So bx minus a square minus b square divided by 4 is equal to 0. Okay, so now this term, this constant term we need to take in the RHS. Okay, so that I am taking here x square plus bx is equal to a square minus b square divided by 4. A square plus a square minus b square divided by 4. Okay, now what we are going to do, we are going to take the half of the coefficient of x, half of the coefficient of x, or the half of the square of the half of coefficient of x. What is the coefficient of x? Coefficient of x is b. Okay, coefficient of x is b. So we will multiply here by half. So what is going to get? B by 2 into x. Okay, now this term will be b by 2 into x. So we are going to add the square of this, square of coefficient of x. So b by 2 square. Okay, we are going to add this term in both the sides, in LHS also, in RHS also. Okay, so that I am doing here x square plus bx plus b by 2 bracket square is equal to a square minus b square by 4 plus b by 2 bracket square. Okay, both the sides we have added, means the equation is equivalent. Okay, because same are added in LHS and RHS, so is equal to sign is constant. Are you getting what we have done? We have taken half of the coefficient of x, we have taken the square of that, and we have to add in LHS and RHS in both. Okay, so now I am taking this step here. What we can do? X square plus bx, x square. So see here x square as it is I am taking plus. Here suppose we will multiply by 2 and we will divide by 2. Then the constant, this step will remain, this term will remain as it is. Okay, so see here 2 into b divided by 2 into x. Okay, the same term we have written in that manner. Okay, 2 into b by 2 into x. So I can suppose 2 will be cancelled, again bx is going to remain, which is our original term. Okay, so 2 into b by 2 into x plus b by 2 bracket square, b by 2 bracket square, that is b square by 4, or you can keep as it is, no problem. Understood? Is equal to, what is there? A square minus b square. Here see, if you take the square of this, then what you will get? B square upon 4. So directly I am taking, adding b square upon 4, b square upon 4. Okay, b square upon 4. Here denominator is same, so I have taken only once 4. Okay, so now here we can do b square gets cancelled. Okay, so what is going to remain in RHS? A square divided by 4. A square divided by 4. Okay, now we need to think about the LHS. Okay, this is the expansion of x plus b upon 2 brackets. This is the expansion of x plus b upon 2 brackets square is equal to a square by 4 is equal to a square by 4. See, x square b upon 2 square is b square by 4, and product of these two is x into b by 2 its twice, x into b by 2 its twice. Okay, so this is the compact form we have taken. This is the expanded form of the identity a plus b brackets. Okay, according to that we have done. So here this a square by 4 I am taking here a square by 4. Okay, now if I am going to remove this square, then what is going to happen? X plus b by 2 is equal to plus minus under root a square by 4 plus minus under root a square by 4. Okay, a square we can take outside, it will be a, and 4 also we can take outside, that will be square root of 4 is 2. So x plus b by 2 is equal to plus minus a by 2 plus minus a by 2. Okay, now we will set this that side in RHS. So x is equal to minus b by 2 plus minus a by 2 minus b by 2 plus minus a by 2. So now we can write this x is equal to minus b plus a, once we will take plus divided by 2. So this we can write a minus b by 2 also. X is equal to a minus b upon 2. Secondly we will take x is equal to minus b minus a divided by 2. Minus b minus a divided by 2. Okay, minus b minus a divided by 2. So this, suppose you will take minus sign common, then we can write minus b plus a divided by 2. Okay, so these are the two roots, okay, of the given equation. This is we have done by completing the square. Okay, method of completing the square. Okay, once again see what we have done. This was the given quadratic polynomial. We have divided by 4. Why we have divided by 4? Because we need to convert the coefficient of x square into unit. Okay, so when we will divide, that time only coefficient of x square will be 1. So we have divided by the same coefficient. So all the three terms. So here 4 cancel, these two terms remaining. Here divided by 4. This we have taken in RHS. We have taken half of the coefficient of x, that is half of b, that is b by 2. We have taken square of b by 2, that is b by 2 bracket square we have added in LHS and RHS. Then this dx term we have written 2 into b by 2. Okay, the term is same here. Okay, why we have done? To bring in the proper form, a plus b bracket square, a square plus b square plus 2ab. So this is 2ab. To bring in the proper form, to use its compact form, we have taken this. Okay, so x plus b by 2 bracket square is equal to a square by 4. X plus b by 2 is equal to, when you will remove this square, that time there will be plus minus, and RHS we have taken under root. So a square is a and 2, and then we have shifted this both the sides, and we have two roots. Okay. Okay, one more example we have taken. Find the roots of the following equation: a square x square minus 3abx plus 2b square is equal to 0 by the method of completing the square. Okay, same, with the help of same method we are going to solve this. So we have x square x square minus 3abx plus 2b square is equal to 0. This is the given quadratic polynomial, quadratic equation. Okay. Now, as usual, what is the coefficient of x square? Coefficient of x square is a square. So we need to divide to the whole equation by a square. A square. So a square x square divided by a square minus 3abx divided by a square plus 2b square divided by a square is equal to 0 divided by this will be 0. So directly we have taken 0. Now see here, this step we can avoid. Okay, directly also we can write. The next step you can write directly, because a square divided by a square will be, these two terms will be cancelled. So what is remaining? X square minus here this a, and from this one a will be cancelled. So what is remaining? 3b upon a into x. Okay, and this term is going to remain as it is, so that will be shift in the RHS. Okay, so is equal to minus 2b square upon a square, 2b square upon a square. Okay, so now here we need to do, now what we need to do here, we have to take the half, the square of half of the coefficient of x, and that we need to add in LHS and RHS. Okay, so half of 3b upon a, 3b upon a, what is going to get here? 3b upon 2a, 3b upon 2a, half of coefficient of x. What is coefficient of x? 3b upon a. Okay, only coefficient we need to use. Okay, so that we have taken. If minus sign we will take, then anyhow we are going to add the square. So square of any negative this will be positive. So not necessary to take minus sign. Okay, anyhow it is going to be positive. Okay, so 3b upon 2a. So its square we are going to add in both the sides in LHS and RHS. Okay, so now I am taking this here x square minus what we will write here? 2. This is the same form, 2 into 3b upon 2a. 2 will be cancelled, again 3b upon a is going to remain, upon into x plus 3b upon 2a bracket square is equal to, RHS is minus 2b square upon a square plus 3b upon 2a bracket square, 3b upon 2a bracket square. Okay, we have added this square in the LHS and RHS, both the sides. Okay, now see, again we will see here, now this is 3b square is 9b square upon 4a square. Okay, so that I am going to take as it is x square minus 2 into 3b upon 2a into x plus 9b square upon 4a square, 9b square upon 4a square, 9b square upon 4a square is equal to minus 2b square upon a square plus 3b square will be 9b square, the same will come 9b square upon 4a square, 9b square upon 4a square. Okay, so now we need to make here denominator same. Okay, so we will multiply here by 4 and here also by 4. Okay, so that I will equals here, that is 4 to the 8 minus 8b square upon this, now denominator is same, so 4a square we can use directly, plus 9b square. So what is going to get? 9b square minus 8b square will be b square upon 4a square. So RHS we have now. Now what is the compact form of this? That we can write here x minus 3b upon 2a bracket square, x minus 3b upon 2a bracket square. See, check, you can check, x square plus 3b upon 2a square, 3b square is 9b square, 2a square will be 4a square. Product of these two, x into 3b upon 2a, it's twice. Okay, you can cross check here your answer. Now this only same term I am taking here, 3b upon 2a bracket square. Now if you will remove the square, the procedure will be x minus 3b upon 2a is equal to plus minus, we are removing its square, so it will be under root b square upon 4a square. Okay, so x minus 3b upon 2a is equal to plus minus b square will come outside, b upon 2a. Okay, square of b square, root of b square upon 4a square will be b upon 2a. Okay, so now we can say here x is equal to, this term will be shifted in the RHS, that is 3b upon 2a plus minus b upon 2a. Okay, so now that I am doing here Is it possible to see? Okay, so see here I am doing 3b, x is equal to 3b plus b upon 2a, that is x is equal to 4b upon 2a, so 2 to the 4, so x is equal to 2b upon a. Okay, so this is the first root, and second will be x is equal to, or x is equal to 3b minus b upon 2a, 3b minus b will be 2b, 2b upon 2a will be b upon a. So this is the second value of x. So x is equal to 2b upon a, x is equal to 2b upon a, and x is equal to b upon a. Okay, so this is the second example which we have seen by the completing the square. Okay, got it everyone? Okay, after this we are going to see quadratic formula. Okay, so solve these examples and then we will see quadratic formula, that is Siddharth Charya's formula. Thank you very much.